Okay, guys, so this is going to be just one problem, but it's with four separate parts. And we're going to be needing to use these formulas that we've been using the past two phases. So, okay, here it goes. So an object moves on a vertical line in the time interval from 0 to 16 seconds, such that its acceleration is a of t equals radical t feet per second per second. And at time t equals 0, v of 0, the velocity at time 0, equals negative 18 feet per second. So part A, find a formula for the velocity of the object at any time t. Okay, so let's do that first. Now there's a couple ways of doing this. I'm going to rely on this formula. Where did I put it? Yes, okay. So it's the antiderivative with integral formula. Okay, and it says that f of t is equal to f of a plus the integral from a to t f prime of w dw. So this formula allows us to, if we know the derivative of a function and we want to go backwards to the antiderivative, we could use this formula to get it, okay? And usually it's most helpful when you want the antiderivative at a certain value. But it is used so much, it comes up so much on the AP test that I just want to use it like for teaching purposes whenever we can. But there's another way to figure this out. Okay, so yeah, so I'm going to use that. So find a formula for the velocity of the object at any time t. Guys, it's important to know that if you're comparing acceleration, if you're looking at acceleration velocity, acceleration is v prime, okay? So for part A, if I use that formula above, I've got v of t equals v of 0, because that's what I know, plus the integral from 0 to t, v prime of w dw. Okay? But I know v prime is acceleration, and I know acceleration is radical t. So in here, I'm going to put radical w, but I'm going to put it w to the 1/2 so that I could use the power rule. So this is v of t equals v of 0 is negative 18 plus the integral from 0 to t, and then w to the 1/2 dw. Okay, now I'm going to use the fundamental theorem of calculus. That's where you do the brackets. You take the endpoints of the interval, put them over there, and then inside of these brackets goes the antiderivative of this. So w to the 1/2, you got to add 1 to 1/2. So 1/2 plus 2/2 is 3/2. So it's w to the 3/2, but then you've got to divide by 3/2. And remember, there's like a 1 out here. So 1 divided by 3/2, keep, change, flip, it's 2/3. So 2/3 out front like that. Okay, and then the way that it works is you plug in the top, which is t, minus you plug in the bottom, which is 0, so that makes the whole thing 0. So I'll just go over here. So v of t is equal to 2/3 t to the 3/2 minus 18. Okay, so that was for part A. All right, so that was part A. Now for part B, set up an integral to find the displacement in the interval 0 to 16 seconds. Use your calculator to evaluate the integral. So the displacement is this formula. So this is part B. So the integral from 0 to 16 and then the velocity goes inside of here. So 2/3 t to the 3/2 minus 18 dt. And that equals, all right, now I'll show you in the calculator. It is, so you go you go math 9. Yeah, math 9, 0 to 16, 2/3 x to the 3/2 minus 18. Okay, oh, shoot. 2/3 x to the, because it's minus 18. There it is. Okay, negative 14.933. Negative 14.933. Okay, so, yeah, so that means that the net change in position from 0 to 16 is 14.933 feet to the left. Okay, So, okay, now, part C. Part C. Okay, set up an integral to find the total distance traveled in the time interval 0 to 16 seconds, and then use your calculator. So the total distance traveled is this. So it's the integral from 0 to 16, absolute value of 2/3 t to the 3/2 minus 18 dt. All right, and when you use this, guys, so I won't do the whole thing, but you hit, you go math 9, 0 to 16, and then if you want absolute values in there, you hit math, and then you go right to number, and you hit enter. And then you just plug in the velocity function inside of those absolute value bars. Okay, so I already did this, and it ends up being, this should say feet. Okay, and this ends up being 179.467 feet. Okay, now let me pause to say one little thing. The displacement tells you basically how far you are. It tells you how far to the right or left you are at time 16 compared to time 0. Okay, so what we know by this number is that at time 16 we are 14.933 feet to the left of where we were at time 0. Okay, that's what displacement tells you. It doesn't tell you total distance traveled. Look at this, guys. The total distance traveled is much bigger than that. So this particle must have changed directions, a lot. Now, so the displacement, and I'll make us some exercises that like fortify this concept, but displacement is always going to be less than or equal to total distance. And if displacement is ever equal to total distance, that means that the particle never changed direction. Okay, if the particle changed direction at all, then some stuff is going to cancel it out. Some stuff is going to cancel out. So so if the particle changed direction at all, displacement will be less than total distance traveled. And total distance can never be negative also. Okay, now D. When is the particle moving to the left and when is it moving to the right? Okay, guys, this is where, let me go get it actually. You really need to know Susan's table. The physics version for this one. Okay, so this is at the very beginning of your packet. Okay, and I know I've printed this out for people, so you should, probably a good idea to have it in front of you when you're doing these types of problems. But the particle is going to be moving left or down, which are negative directions, if velocity is negative. The particle will be moving right or up if the velocity is positive. The particle will be at rest if the velocity is 0. So, Oh yeah, and the particle will be changing directions if velocity has a sign change. So I've got to figure out first where the particle is at rest. So those are like the critical numbers. That's where velocity is 0. And then I'm going to do like a little sign test, a little number line test to see where the velocity is positive or negative. Okay, so I've got to take the velocity. So the velocity function is this, and I've got to set it equal to 0. So 2/3 t to the 3/2 minus 18 equals 0. So 2/3 t to the 3/2 equals 18. I divide both sides by 2/3. You do keep, change, flip. All right, so I'm really multiplying this by 3/2. So we end up getting t to the 3/2 equals 27. All right, if that doesn't make sense to you, think about it, but I do 18 divided by 2/3, so that's 18 times 3/2, and then you end up getting 27. All right, now, how do you cancel out a 3/2? Like this, okay? So I'm gonna raise both sides of this equation to the reciprocal of 3/2, so to the 2/3, to the 2/3. What's 3/2 times 2/3? That's 1. So we just end up getting that. Over here, we just end up getting t to the 1st equals, now I'm doing this without a calculator. You could use a calculator, but I thought we should practice this. And then 27 to the 2/3, that's the cubed root of 27 squared. Okay, that's t to the 1st, by the way, not t prime. All right, then you get that t is equal to, guys, the cubed root of 27 is 3. And then t equals 9. Okay. All right, so that is our critical number, is 9. And now I'm going to do a number line. Velocity. Okay, so I've just got, I've got my endpoints. So 0, 16, 9. All right, so 9 I'll put right here. Okay, so you know what, guys? 0 and 16, they're endpoints, but they are also part of the intervals to the left and right of 9. 0 and 16 are not critical numbers. So you could, in fact, use them to plug them in to the velocity if you want, or you could use like 1 or something. I'll use 1. So if you plug 1 in to the velocity function, do you get a positive or negative number? You get a negative number because you get 2/3 minus 18. So this is negative. Now, if you plug, like, I don't know. I'm trying to think of something with a, I don't know. Plug in like 8 or something. Actually, if you plugged in 16, that'd be nice. Because because 16 to the 3/2 is the square root of 16 to the 3rd, which would be 4 to the 3rd, which would be 64. Okay, but anyway, guys, I think, let's just use our calculator. All right, so pick a number to the right here, and like 2/3 times 8. No, 8 is not there. I'll use 10. 10 to the 3/2 minus 18. And you get a positive number. Okay. All right, so the particle is moving left from 0 to 9. I'll explain why I included 0. And it's moving right from, and I'll use units, from 0 to 9 seconds, and then right from 9 to 16 seconds. Now, the reason I'm including the endpoints is because, like I said, those are just endpoints. They are not critical numbers. So this number line, guys, continues. So really, if we were not thinking about just being on this interval from 0 to 16, the particle would be moving left from negative infinity to 9 and right from 9 to infinity. All right, so 0 and 16 are really included, within these intervals, positive and negative intervals to the left and right of 9. Okay, so I'm including them. Yeah. Okay, guys, so there's that.